So welcome to a presentation. Sebastian, Piotr and I, we worked on Kaapana. This is a platform provisioning toolkit that can be used to make data analysis pipelines in medical applications more convenient, to apply machine learning algorithms and also data analysis algorithms directly to the clinics and to deploy them there, and to have a central place to store the data and to conduct trainings and also other machine learning algorithms maybe. We were all not familiar with this platform before, so we had to start right from the bottom, like setting everything up and installation, which took quite some time, but we will come back to that later. Also, we had to upload our data to Kaapana to be able to test our algorithms. And also, as I said, we were not really familiar with it. So we first wanted to apply the built-in NN unit to some exemplary abdominal scans to get a feeling for the navigation on the site and see some first results soon. And that worked quite well. But of course, it was a lot more interesting to containerize our own methods, our own algorithms, and also to deploy them there. And I think we were quite successful in creating a couple of algorithms, or like applying a couple of algorithms to our data directly on Kaapana. And we would like to present the main results in the following. So just for the sake of completeness, here's a screenshot from the NN unit prediction. As I said, this model is already built in Kaapana, and but it's also quite handy to visualize all those predictions, the multiple classes. You can scroll through the 3D scan. That works quite well, and we were very fast and got good results soon. So there was nothing to do about it besides like clicking the right buttons, I would say. But what was a lot more interesting was applying our own methods. And that's like one thing we did is we did image registration on brain MRI scans based on the ANTS toolbox. And this algorithm basically takes an input image and the template and registers the input image to the template. And the question was how to do that with Kaapana. And the main thing is that the Kaapana flow is based on airflow. So you always have to create a Docker image and wrap this Docker image into another operator, Kaapana operator, and then you get what you see like on the slide, those directed acyclic graphs, which basically represents the processing pipeline, first loading the data, then converting maybe the data type, and then performing the image registration in this case. And then we want to store it again and clean everything up. And we were successful in this image registration task, and it worked quite well to do that on Kaapana. Now I think I'll hand over to Piotr.
Thank you, Fabian. So the second method, the second algorithm that we deployed on Kaapana was voxel-wise or patch-wise extraction of radiomics features. And for that, we needed segmentation masks, and we used the masks that we got from NN unit, from the pre-trained models. And the flow, as you can see in the middle, the flow required the mask and an image an image matching to the mask, and then they were both converted into Nifty and based on PyRadiomics a method, our model created basically parameter maps describing particular radiomics feature. As you can see in the example on the bottom, for CT abdomen, we segmented spleen with an unit, and then you can see an example of the distribution of uniformity radiomics feature for spleen, which is a measure of homogeneity of the image. Thanks.
All right, then the next task was also a segmentation task, but this time on brain MRI. And for this, we integrated this FSL toolbox for segmenting neuroimages. So similar to the task before, we had basically this DICOM to NIFTY converter in the beginning. Then we had to have a Docker container that does the actual segmentation with FSL. And then what we wanted to do is to also display these segmentations in this built-in DICOM viewer that Kaapana provides. That was actually the most difficult task, because also FSL works in NIFTY and produces NIFTY segmentations, but in order to display them, you have to convert them back to DICOM. And especially Kaapana supports this for an unit already, but since we are working on the brain MRI, it didn't support these structures we were segmenting, so like hippocampus or amygdala. So basically you had to write a mapping here that defines like which label in this label map produced by FSL corresponds to which name, and then convert with this information, convert the segmentation map to a DICOM. And then once you have this DICOM, you can again upload it to the Kaapana DICOM server, and then you can overlay the segmentations obtained by FSL, as you can see on the image on the right. And then you can switch them on or off as you would expect from a viewer. Yeah, can go to the next slide, please. Right, so these were our 3 tasks. Now we want to talk a little bit about the process of how we experienced it. So in the first day, we spent quite a bit of time on setting the whole system up. So the lesson learned here is basically that you should start from like a bare bone server, a fresh install of Ubuntu in our case. And the second thing we eventually realized is that this needs to be a powerful server. So you need plenty of memory, plenty of disk space, and CPU cores. Otherwise, this is not fun working with this. And then it also supports GPU processing. So you need to install NVIDIA drivers, like for example, for NN unit. And then the next step is provided, luckily already, a script in the Kaapana repository to set up the Kubernetes platform together with Docker. So that's relatively quick. Then you would need to build the Docker containers. We could skip this part because Klaus gave us access to a Docker registry which has these images already pre-built. That was quite nice because you have to build, I think, something like 60 to 80 Docker images in the beginning. And then the next step is basically to initialize this Kubernetes cluster with all these Kaapana platform containers. And there's also a script provided, and this takes some time. So you basically need to watch there until this process is done. In our case, it took about 30 minutes. And then you can finally log in, set up your initial account, and then upload the data. In our case, we did this with a DICOM send command. Since Kaapana is compatible with DICOM, this works seamlessly, and then you could access it from Kaapana. Go to the next slide, please. And then once we set this up, there was this development process, how to integrate your own workflow or your own operators. As Fabian already mentioned, there are 4 main components. So you need to write some code that does the actual processing you want to achieve. Then you need to wrap this code in a Docker image such that you have all the dependencies to run it. Then on top of that, you need to define a Kaapana operator. That's again a Python class you have to write, which specifies what's the Docker image and what resources it requires. For example, if you need a lot of memory, you need to specify, so you need a GPU, you need to specify it. And then the last step is defining a workflow where you basically connect different operators together. And this is done in Airflow. And it's again a Python script essentially. To do this, you kind of need at least basic knowledge across all of these different stacks. So you need to at least know how to define a Docker image, how to define the operator in this workflow. The good thing is that the Kaapana repository has some basic examples. And in our case, we used basically this as a starting point and then modified it in the way we needed. And also then in unit workflow, especially for this FSL segmentation, was quite useful, and we adapted it to our needs. Debugging is a little bit tricky, I would say. You can do it over this Kubernetes dashboard, kind of where you can either look at the log messages your container produces or directly log in with a shell to a container. The other thing we noted is that like finding which operators are available and what options are there to define them is currently not very good documented. So you need to ask Carl at the moment, is probably your best guess. And in my case for this FSL, as I already mentioned, this storing the segmentations in DICOM was actually way more effort than actually implementing this segmentation Docker book with the Docker. Yeah, can you go to the next slide? Can you go to the next slide, Fabian?
I think it's the last one, isn't it?
Is it the last one?
I think it's the last one, yeah.
Okay, yeah, so this was basically our work on this project. I think in general, this Kaapana platform, I think it's quite cool that you can integrate all this stuff, but I think at the moment there's not so many things, but like once this like community grows and more people like add workflows and things like that, I think this could be really cool and basically make algorithms that are out there much more accessible, because once you went through this process and set it up, it's basically just selecting the images you want to process and then selecting with the workflow and pressing start. And yeah, I think we had a lot of fun exploring.
Absolutely.
Kaapana.
That was nice.